Hi, in this video we will do examples for orthogonality test. To check if two vectors are orthogonal or not, we need to find their dot product. If the dot product is 0, then they are orthogonal. Otherwise, they are not. Okay, let's start with the first pair. The vectors are 1, 2. We have to dot it to the -6 and 3. The first component times the first component, second component times the second component, and add them. This is -6 plus 6. It is 0. The dot product is 0. Then orthogonality test says that they are orthogonal. For the second one, 2, -1, 3, dot, -3, 1, and 1. So this gives us first component to the first component, second component times second component, third component times the third component, then add them. This is dot product. This gives us -6 minus 1 plus 3, which is -4. -4 is not 0. The dot product of the vectors is not equal to 0. Then the orthogonality test says that they are not orthogonal. The third example are the vectors are given in IJK form. So we first find their component form. So 1, -2, and 3. The other one is -5, 2, and 3. We dot product. So there is 1 times -5, -2 times 2, and 3 times 3, and add them. This gives us -5, -4 plus 9, which is 0. The dot product is 0, so then they are orthogonal. How about this last one? Well, the vectors are not given explicitly, but the vectors are supposed to be the equivalent vector to the corresponding to the line segments from a point to other point. Remember, to find the equivalent vector, you need to do the components of the endpoint. For example, for this one, endpoint is 3, 2. So we do, for the first component, we do 3 minus 1 and 2 minus 0. So the vector, the first vector, which is equivalent to the direct line segment from 1, 0 to 3, 2, is 2 and 2. How about V? V is the vector which is equivalent to the directed line segment from 1, 2 to the origin. Origin, remember, has the coordinates 0, 0. So we have 0 minus 1, end point minus the starting point, 0 minus 2. So this is -1, -2. Now I have two vectors. To check their orthogonality, we need to find their dot product. So we find the dot product. This is 2 times -1, 2 times -2, and then add them. This gives us -2 minus 4, which is -6. The dot product is not 0. As a result, the vectors are not orthogonal. And that was some example to check the orthogonality. To check the orthogonality, you just need to find the dot product. If it is 0, they're orthogonal. Otherwise, they are not